picture and you can tell a story almost right away with that picture. Here is a question: how much data is needed for a network? Can you work with sparse data? This is an excellent question, because with regular data analysis, we need to have samples and we need to have that central limit theorem requirement. With network, you can have as few as 2 nodes. That's called a dyad. And the smallest unit of analysis in a network is a dyad. Smallest unit of a structural analysis, where we can look at power, is a triad. So you can have as few as 2 data points, and you can look at the relationship, for example, over time. Of course, you might want to have more, but can you have sparse data? Yes. Sparse data, when you have one person and his or her connections, and then another person and his or her connections, are called ego network data. You don't have to have large connected networks to analyze. Ego network analysis, in fact, is a very powerful method of analyzing data. So you can have small clusters. You can talk to your friends, ask about who their friends are, and you've got yourself a network. So we don't, in network analysis, we do not have that stringent size requirement that's really suggested for other methods of analysis. And the relationship between network analysis and graph theory, there really isn't any difference. If you think about it fundamentally, if you take a big picture perspective, graph theory, of course, appeared a little bit sooner, well, a couple centuries sooner, right? Network analysis is graph theory applied to social settings. So we call it social network analysis. But networks, graphs and networks are the same. We have the same terminology. In network analysis, we use terminology a little bit more loosely. Like I said, there is a node and there is a link, right? Well, in graph theory, there is a node, but then there are edges and arcs, and that depends whether those arcs are directed or undirected. So in network and social network analysis, we don't really go into the distinguishing between those arcs, edges, ties, links. It's all the same thing to us. When we have a tie between 2 nodes, we just specify whether it's directed or undirected. All the methods used in graph theory are fully applicable in network analysis. It's practically the same thing. To make it simple, let me put it this way. Graph theory is used by mathematicians and computer sciences. That's what this field is called in there. And networks are used in elsewhere. And there is a question applied to social sciences, only social sciences? No. Network analysis and graph theory, which, like I said, it's practically the same thing, just different terms, can be used anywhere. The reason why we distinguish social network analysis, because social means that there is a relational aspect present. What does it mean to have a relational aspect present? That means that a node has to be able to make a decision. So if the node makes a decision who to connect to, and that decision is not programmed, because of course, when you have electric power transistors or transmitters, that's a network also. But those power transmitters don't make a cognitive decision, right? They just transmit power if they have enough capacity, they shut down if they don't have enough capacity, or I don't know what they do. They are not social creatures. They don't make cognitive decisions. So when we say social, we mean that our node makes a cognitive decision. That's why we call it social network analysis. Otherwise, it's network analysis or graph theory if you prefer. In fact, in our laboratory, we have some people who call themselves graph theorists, and we have people who call themselves network analysts, and guess what? They do the same thing. Another one is country trade. That's how countries, and that's, I think, all 218 of them, which countries trade with which, and this is done in a form of what we call a block, right? So when we combine the data into, instead of a graph that you see here, a picture, we have a matrix. So we have a sociogram, which is a graph, and a sociomat matrix, which is how the data are located, a series of 0 and 1s. So I guess you can present data and you can do many things with it as much as you want when it comes to networks. So what else can networks do? Well, guess what? Here is a Harry Potter network. Of course, Harry James Potter is the central figure in this Harry Potter books, right? And you can tell who he's connected to and less connected to, and literally works get analyzed with network data. And here is the Lord of the Rings, and you just from the way that it's drawn, you can tell there are different camps there, right? So, as I said, network analysis is immediately inferential. You can look at the graph and you can tell a story about what happens there. And networks can do what other methods cannot. And this actually is my favorite story about networks, even though it's a little bit old by now. This is, it's the COVID. Yeah, it looks like the COVID, thank you. This is a story from 2016 when Donald Trump became an American president. Now, it's an interesting story, and it used to be an interesting story for 4 years because for many people, that was a surprise win. Most of the polls, social polls, predicted Hillary Clinton to become the next president. And in fact, everybody was so sure that for several months, all the polls were showing Hillary running substantially ahead of Donald. And she was given like a 73% chance of Donald's 27 to win this election. Okay? Well, Trump won. And I want to show you the snapshots from several news, and they're all over here. Now, notice this says October 31st, 2016. That's a week before 2016 election, which took place on November 6th or 7th. Now, here's another one. This one is March 7th of the same year that predicted Trump win with 87% certainty. So that was 6 months before the election. In fact, this model has predicted that Trump would win. Doesn't matter, no matter who is elected the Democratic nominee, whether Bernie Sanders or Hillary Clinton. If Trump secures the nomination from the Republican Party, he's guaranteed a winner. Now, if Trump loses the nomination from the Republican Party, then again, it doesn't matter whether it's Hillary or Bernie, whoever is the Democratic nominee wins the election. That was on March 7th, before it was known that Trump would become presidential nominee. On what basis it was done? An excellent question. This actually shows here, it was just about 20 million, and it's not that many because in the age of large data, 20 million posts is nothing, of social network data analysis. So networks, social networks, the posts, the sentiment on the networks, things that people were saying online actually showed that they supported Trump. Okay, so was it a big disconnect between what people said online and what they said to the pollsters? Was it the problem with the methodology of the pollsters? I think it's actually the same thing, or actually both are true at the same time. That's what I want to say. I want to say that sociological methods removed from network analysis actually do not give that full picture of what's going on because people are connected. When we make those statistical samples and when we make predictions, we assume we are all independent. We are not independent. If you grow up in the United States on one of the coasts, doesn't matter whether it's west or east, if you're from the coast, you're most likely grew up in a democratic environment, you're going to be voting Democrat no matter what. If you grew up somewhere in between, Midwest, Southern Belt, you're going to be voting Republican no matter what. So you're not independent. You're dependent on your social environment. And most methods ignore that. Social network analysis does not. Network analysis does not, graph theory does not, okay? So we're going to call them the same. And another thing, Liberia's Ebola outbreak, it was traced to one source, a 2-year-old boy who was bitten when the Ebola actual outbreak happened several years ago, much more devastating, of course, than the COVID disease. So again, network analysts were the ones who were able to trace the disease to the source, and they were able to stop the disease from spreading by cutting off all the relevant links. Now, that didn't happen with COVID, unfortunately, because, well, for one hand, that was too late. The disease was diagnosed as a separate disease for a while. It looked like a pneumonia, it looked like a respiratory tract infection for a while. And the virus was not isolated for a while. Second, it was spreading so fast. And there, I mean, you can read about all the reasons, but It's the network analysis that predicts how it would actually go further. And there is a lot of information about that. So in some isolated regions, we can just close off the country or the region, the spread of the disease stopped very quickly, like let's say in China. So, well, the future of network analysis looks very bright. Just like I showed you, networks can be applied everywhere. Like I said, I can't think of a situation when it cannot. So this is a job market prognosis for network analytics, and it's actually even more optimistic than the data market in general. Everybody wants to be data scientists and data analysts and biostatisticians and whatever name people call themselves. It's all about data analysis. We have data and we have analysis. Now, how you call yourselves is a different story. Now, network analysis actually grows faster. And here we are, by opening the Master of Data Network Analytics program, we are not only responding to the demand of the market, we anticipate that demand because the compound annual growth rate of network analysts is expected to be about 20.5%. Now, there are actually very few programs in the world that teach this wonderful method, systematically teach it. You might take some classes, or you might actually take an online degree, but to make it a part of a systematic training, there are only a few programs in the world that do that. How is network analysis different from data analysis? So there are two questions. Prediction made by network analysis. Actually, I don't know how the prediction is made. This is a market report. It's Markets and Markets. The link is in there. You can actually check it out and look at the methodology used. Normally, when people make forecasts, they use either dynamic linear modeling, which is ARIMA and ARIMA type models, or they use some kind of other forecasting tools. Sometimes now actual machine learning does a very good job of predictive analytics. We can build longitudinal models with networks, but they're actually a little bit different. In networks, predictions are focused on predicting a tie formation, whether or not the two people will form a tie. For example, when Joe Biden became a president, network analysts could easily tell who he's going to pick out of his immediate circle based on their characteristics as his cabinet members. That's what networks do. Networks usually don't focus on those linear predictions as you hear. So I don't know the methodology. If I were to guess, I would say it's either dynamic linear modeling, or it is one of the more advanced forecasting methods. So I will answer the questions in the order they were received. How is network analysis different from data analysis? It's not. It's the same data. As I've shown earlier when I was drawing those pictures, you analyze the same data, plus you also have connections between nodes. So you have additional information about all of your nodes and how the information and other attributes can propagate from one node to the rest. Can network analysis be used in natural disasters, hazards turned to disasters? Yes, you can actually use network. Those are called contagion or diffusion models, where you can look at how fast something can propagate. For example, how fast the fire would spread given, let's say, forest density. Each tree is a node, and whether or not that node gets infected can be modeled by network analysis, or some spillover effects, or natural disaster could be a COVID, right? So absolutely, networks can be used for that with special models called contagion or diffusion. And the analytics market in general is actually very optimistic. So thank you for the question. I will answer that in a second. I just want to say, because actually what the question is, what sort of background is ideal for somebody who is interested in our master's program? Let me finish the slide, and this is one. Now, the 90% of all the data we have today, think about it, that all the data we have available were generated in the last 2 years. So up until 2 years ago, all the humanity, starting from the time when we were learning to count, animals killed on a little piece of bone, right? So many thousands of years, that were all data. So up until 2 years ago, we generated 10% of what we have today. And then 90% in the last 2 years. Well, there has to be someone who will be there to analyze that data. Now, in which fields do we have data? In all fields. In fact, show me the field where we do not have the data. I mean, I can't think of, because everything we do with data. I showed you, we can analyze books with networks. Books are data. Texts are data. Text mining, sentiment analysis, emotions are data. Sentiment analysis means analyzing emotions in written works. So because the data applicable everywhere, of course, biology, medicine, and economics, finance, those are naturally more data focused programs, right? I mean, data focused fields. More so than, for example, literature. Literature has one type of data, that's texts. And then they can do so many different things with text. Now, economics might have text and might have numbers and they might have networks and whatever else. But if you think about it, data are present everywhere. Therefore, in every field, you will need to learn how to analyze the data. And in our program, we have people who had absolutely no background in data analysis. They were lawyers, for example, who came to study, and they've learned the data analysis so that they can apply in their field. So when you're saying what kind of background, any background. For our program, we take students from every background. We only require that you have a bachelor's degree. You don't even need to have any understanding of data analysis. We start from ground zero. We start from scratch. And we teach you how to use data in your field using applied projects to work with your particular data, okay, to become a data analyst. So what sort of background? There is no ideal background. The only requirement is you want to learn data analysis of any type. Text mining or big numerical data, does not matter. Other comprehensive masters, how we compare with them. In addition to everything that other comprehensive masters offer, we have two big differences. First of all, of course, networks, right? Because very few people teach networks because it's a new field, not very well developed. Social network analysis as a field only really started to take off in the last, I would say, 20 years. Before that, it was developing a social network analysis. And as I showed you with Milgram, it was 1950s, 1960s before it even came to being, while mathematicians and computer scientists use graph theory much longer. So it's a new field, first of all. Second, it's not very well, of course, known, but the demand for network analysts is huge. The second big difference between us and other programs is, think about this. If you had a course in statistics, do you remember what you did in that course? Let me remind you, because I don't know where you studied statistics, but I'm ready to guarantee that you all have studied statistics with a definition of what statistics is, the difference between a population and a sample, descriptive statistics of a sample, for example, graphs, charts, numerical descriptions such as average, standard deviation, and variance. Then you maybe did analysis of variance, maybe then you did regression analysis, and maybe if you had more advanced statistical methods, you would have learned logistic regression, factor analysis, and something more advanced. But it has always propagated from that, in that linear fashion, from population versus sample, describing the sample, and analyzing the sample, right? Wrong. I mean, that's what's wrong about analysis, because in real life, we don't start with population versus sample. This is how research is done in scientific fields. When, for example, you do have an ability to design your own experiment, so you can calculate the sample size and you can decide which power of the statistical tool you need. In real life, let's say you work in a company, and at the end of the year, you have your sales numbers, right? You have to take the sales numbers and figure out why your sales numbers are lower or higher than expected. Because if they're lower, you have to fix something in order to rise them up. Or if they're higher, you want to understand why they're higher so you can repeat your success. Do you really have time to look for all of those averages, standard deviations? Yes, you will calculate them. But on your data, they will not tell you anything. I mean, you will have an average of your sales, great. Standard deviation, also great. What do you do next? So the big difference in our program is we start with a problem. When you have a problem, Then we teach you what kind of data you need to solve this problem, what methods are appropriate for these data, what methods you can derive, how can you build a network out of your data, because some networks are secondary, they can be generated from the data you have. And how do you combine methods together to answer the question you need to answer? Our approach is so successful. You can, in fact, look on our website that we have students who have won 4 international Kaggle competitions. Have you heard about Kaggle community? That's 3 million data scientists. That's the largest data science community in the world. They have those international competitions where hundreds of people, hundreds of groups sometimes submit their works. And our students have taken a prize, either first or second place in 4 of them in a year. So they have taken 4 competitions because our program is so new. That's because once they see that data and the problem, they know what to do. And they have done better than MIT, they have done better than University of Washington, and some other best data science programs in the world. That's the big advantage. So our mirror program, which is offline program to data and network analytics, is called Applied Statistics with Network Analysis. So that kind of highlights the fact that it's an applied program. What kind of software used? Amy. I will get to that maybe, or maybe I will actually answer now. We use R, we use Python, we use out-of-the-box software such as SAS, Stata. We use Orange, Visoni, Payek, which is the largest free program, GeoDA, which is a spatial data analysis program that's completely free. So it's whatever you want to do. So we start from scratch and we teach you from scratch. Skill sets required for network analysis, desire to learn network analysis, that's the only skill set. Strong mathematical background, no. We actually learn very little math. Math is available if you want to. We give it in the references. But now the software becomes so powerful that you don't need to know how the mathematics of it works. You need to know how the data work and what the results tell you. So we teach you to run a program and we teach you to look at the results. And as a result, you can analyze something not having any idea about what actually mathematics behind it is. So lots of our students, our lawyers and linguists, we had some students who have never had any mathematical background, they're becoming extremely successful without knowing much math. So how many projects you have to make for this course? Actually, you can, there is a course and there is a program, right? In the Masters of Program, it depends on how many courses you take. You design your own program. You decide what you want this program to be. We have only, I think, 6 required courses, the rest are electives. So if you want to learn to work with geographic data, like spatial data from the word space, right? You can take that course. If you want Bayesian statistics, you can take that course. If you want stochastic, I mean, if you want non-parametrics, I'm not going to say all of these big words. You decide. For every course you take in the master's program, there is at least one hands-on project. But that's not everything, because we also have what is called an analytic workshop. We have a course that's required that's called consulting, where we teach you how to be consultants. And as a result, when you're working with clients, and those are real-life clients, our clients are companies or individuals, students, professors, and people from the society in general, who come to us, to our analytic workshop completely for free, of course, to them. That's a service that our students provide and learn as a result to become more proficient in whatever methods they use. So they end up with lots of projects. Now we have some students who are studying fully online, so they consult their projects online. Well, and this year the whole world is online, so I don't need to tell you about the online project. Now there is a question about pool party semantics use software. I have not heard about that software, so I don't know what that is. So I'm sure that those of our text analysts who do semantic analysis, we offer courses in machine learning and text analysis, and they can probably give you the full range of software. or the packages for R or Python that are being used to do the analysis. Do you need to have knowledge in Python? No, you don't. Do you need to learn R and Python before you register? No. We are going to have an introductory course that will give you basic background in mathematics and statistics, the absolutely bare minimum that's required for you to master this program. Also the very basic of Python, also the very basic of R, and then you're good to go. What tools are useful to identify hubs in Almar network where nodes have many attributes? This is an excellent question, and I think it's a complicated question, okay? Because the fact that nodes have many attributes is actually irrelevant. Nodes might have one attribute or they can have hundreds of attributes, right? So again, the question, the tools that you're using, again, what do you want to do with those networks? If it's community detection, if you want to find the hubs, it's one story. If you want to predict what happens in these hubs, how they form ties and what they do, it's another story. So for community detection, you might actually use regular block modeling, and that would be enough. For figuring out what's going on, you might use complex network models called exponential random graph networks, or temporal exponential random graphs, or Siena, stochastic actor-oriented models. So I'm saying these big names that I know you have no information about. Don't get scared by them. What I'm saying, again, that's an excellent question that demonstrates that our program is so different from everything that's out there. We'll give you the tools, but you have to learn how to formulate the question first. There are many excellent programmers out there who can code in Python or any other language, but really don't know what to do with it once they have that code. They code for the sense of coding. So if you want to identify hubs, I suspect that's community detection. And community detection models take into account many attributes. So you can just, depending on what you do, you can use a variety of tools. But again, we need to know the research question. There's some specific industries or business models that you can see driving the demand for network analysis. Some specific business use cases that represent significant application of this knowledge. Well, this is an excellent question. Are there specific business models? Yes. One very common business model is the model of bank stability. If you think about it, for example, in financial industry, all the banks are interconnected. There's no such thing as an independent bank. Some of them, they are called community, like banks that are formed by communities. If they have enough funds within their little community, they're fine. But as soon as they borrow money from a central bank or anywhere else, they become embedded into their financial network of the country they're in, and now the world. I don't know if there are any banks left in the world, or banking systems, I would say, that are completely independent from each other because of the financial flows. Okay, so what happens? Crisis of 2008 on Wall Street, and there is a very quick drop in the American financial market. Now, I don't know if you remember this story. There was some scandal that involved some of the pyramid schemes. That's not relevant, right? So what happens? The market value of stocks, Dow Jones and S&P 500 drops. Lots of banks have money invested in these stocks, right? So they immediately lose their market value. They have to find that dollars or rubles or whatever money they're using somewhere. So they start borrowing from each other. So those banks that have some assets lend money to other banks, but they want to keep their assets, they raise interest rates. So as interest rates increase, the amount of loans that can go out decreases. So the banking system is going through a shock. And because the overall amount of money in the banking system is a lot lower than the money on paper. You realize that, right? The shocks propagate through the system. Why do I say that there is a lot less money in the bank, in the banking system? Because let's say a person A came to the bank to borrow $100. Well, a bank does not have $100. Bank does not produce anything. Where does the bank take the money? It takes it from the person B that actually brought the money to the bank and put it on the deposit to make money. So the bank takes the 100 that the person B brought in and loans it to the person A to make interest of the person A, pay a little bit to the person B, and keep a little bit of interest to themselves. So on paper, there are $200 in the system. One that the person A supposedly has in the bank, one the person B that the bank gave him that money, right? But in reality, there is only 100 as opposed to 200. So when there is a shock, when there is a market failure, the money that's actually not available becomes highly demanded, and now we get a ripple effect that affects the entire economy, and that's a network-based problem. So can I some specific business use cases? Again, well, I think this is specific business use, and we can probably go through that. But if you're interested, there are excellent network analytic models that analyze the 2008 financial crisis that rippled through the whole world. How many percent of people approve this course? I'm not sure I understand this question. I think what it means is how many people get enrolled. Well, it highly depends on the portfolio, of course, and it differs from year to year. There is no absolutes. We don't have an exam for this course. You submit your portfolio. So basically, you tell us, this is what I've done, and this is why I want to study networks. We look at what you've done, and your field does not matter. How many mathematics courses you had does not matter. What matters is if you have been a good student, and if you are willing to work hard, and you know why you need this program for your future job, for your future profession. That's very important, because the worst thing that can happen is if you end up in the wrong program. Okay, so we want to avoid that. And depending on the year, sometimes we have more, sometimes we have less. This is a master's program. You get Masters of Science. It's not a certificate, it's an actual master's program. How many hours a week? 7 to 10 hours, depending on the course you take and your own ability to study. Typically, we will offer 2 courses at the same time. There is 1 lecture that's recorded, that's between 80 and 90 minutes, that's broken into small intervals, and that you can study at your own pace. And there is a webinar once every 2 weeks for every course. So if you're taking 2 courses, you will have 2 lectures a week, that's an hour and a half, and 1 webinar, that's about another hour and a half. So that's 3 hours of time commitment spent working on the course. And we say that about double or triple of the time will be required for you to master the material, to do the exercises, to work on the project. So it's 7 to 10 hours. So it's either double or triple of the actual required time. And then you can fit it in however you want within your own study program. Is there a recording? Yes, there will be a recording. Since you registered for the seminar and received the link, you will, as a reply, get a recording of the seminar. What are typical topics for master thesis? Can I write thesis with 3 industry companies and not state-governed companies? You can write about anything you want. That's such a wonderful question, because it gives me a chance to brag about my students. Last year we had, well, actually both years we had 2 cohorts of graduates, and students had amazing topics. Last year they were looking for exoplanets. Imagine that. I mean, I've always liked space. I found it fascinating. I mean, we are in this, tiny people on a planet, in a solar system, in a galaxy, just, seems like we're so tiny and so small. And I don't want to believe we're the only ones out there. So, if I did not become an analyst, I would have probably became an astronaut or something. So one student decided she wanted to use the signal, the light signal, and the time sequence of the data to search for exoplanets. That was an amazing study. So completely free. It's not really related to a company at all. So, well, she actually done a wonderful job. She got the highest mark with distinction. It was the best project of the entire cohort. Well, we had people who wrote recommender systems. We actually had that a couple of times for the demand of their companies using different softwares. We had people who used Bayesian methods to evaluate the accuracy of medical clinical trials. We had people who have analyzed fraud in published studies, because network analysis is wonderful for that, and actually any data analysis. We had some very scientific papers, for example, papers on progress of democracy and development of political processes. Those are academic for people who want to go into academia. We had some people who studied online communities or online social networks in a variety of different settings. So it's a lot of different topics. They're so different, I can't even name them all. I would recommend going on our website because their student paper topics are actually listed, and they're in every field, starting with medicine and ending with space and exoplanet search. So you can write your thesis based on your own interests, which is exoplanet. Of course, she was not working in, astronomy. She was a computer programmer. She was just interested in doing that. We had, several people analyzing music. So anyway, you can do it with your interest. You can do it for your company's demands, or you can do it as part of a preparation for a PhD program. We actually have an excellent rate of acceptance of our students into PhD programs. Altogether, about 25% of our students went on to get their PhDs, and they are best universities in the world, starting with some of the European, like Central European University, Groningen, University of Groningen, and Oxford. So, we have actually quite a good track record with that. You have degree in statistics. What's the requirement for somebody to be a data analyst? Well, depending on what kind of degree you have. If it's an undergraduate degree in statistics, then you will probably be taking more advanced courses in our program. For example, you probably had time series analysis as a statistics major, but most likely you stopped at ARIMA, autoregressive integrated moving averages models, and their extensions, because those are undergraduate level program. So in our program, we offer 2 levels of time series. So one that covers everything from basics to ARIMA, and the second one is vector autoregression, state space models, structural equations modeling over time, and some more advanced time series methods. So if you have statistics degree, then we have some advanced Bayesian methods, advanced stochastics, so you can actually do more advanced things without taking the baby steps first. When is the program starting? What the requirements for registration? The program starts in September. You can apply for it now. All the requirements are in the, it's a portfolio, and the portfolio requirements are listed. We will send you a link to our program and all the requirements, which is your, of course, your diploma, your motivation letter, recommendation letters, and then some certificates of what you have done. So it's actually quite simple. We don't make it complicated. We think that as data analysts, we can analyze that type of data quite well. So we'll send you the link so you can check where you can find the class list. We have all the courses listed on our website, and we have it in the form of infographics, so you can see what classes are taken, and then you can also see the timetable. The job placement or placement assistance. Well, I showed you the slide where I said that the demand for data analysts is actually very high, and in fact, it has actually grown even faster during COVID times. Analysts became much more needed. So what is our experience with this program is that our students get grabbed and have jobs before they finish the degree. So we haven't had a situation where a person would be left without a job after finishing our program. So I don't know what we will do. But if such situation had happened, we have a partnership agreement with a company called SAS Corporation that produces business analytics software, and our students can go as interns working for SAS. That's a part of our agreement. So if you don't have a job, then you can work, and of course, many of them work online as well. We have many connections through our analytical workshop and through our university to the job placement market, and outside of the program, HSC has a job placement services that are available to all of the HSC's master students. Here's a comment to the banks. People get trapped by investing. I don't invest. I know this too well. The role of data analysis in the use of auditors to anti-fraud. Again, an excellent question. One of the topics that comes up during our studies in our course called Contemporary Data Analysis. The big issue in fraud detection is understanding that the data are fake, okay? There are statistical ways to tell that the data are fake. By the way, my next webinar is going to be how to detect fake data. And today, if I show you the R and show you how wonderful networks are, you will see that I will show you some actually hands-on tools. I will teach you to detect fake data right during this webinar, right? Because it's very simple. Well, it's not very simple, but there are some simple statistical ways. So one of the aspects of fraud detection is knowing what abnormalities to look for in the data. So when the data look, when they don't follow certain laws, when they don't follow certain distributions, when they don't, because when you look at the numbers are not random. Actually, almost nothing in this process is random. So data analysts, auditors who have data analytics background are much better auditors than those who do not. I didn't tell you about myself, but 8 years of my career was spent in American corporate world, and I did work with auditors as well. So I know what good auditors look for. They look for anomalies in the data, not anything else. Yes, link used for registration purpose, excellent. This is for admission for the program. 7 to 10 hours commitment for 1 or 2 courses, both courses, 2 courses, yes. More information about the program, I think there are some links here that you can follow. Suggest the program to experienced professionals. Again, this is a question of what are you experienced in and what do you want to learn. If by experienced professional, you mean someone who has 20 years of experience in whatever field, well, we have plenty of those. In fact, when the program just opened, our first set of students had an average age of about 34 years. So we only had 3 or 4 students straight from the bachelor's program. The rest all came from the industry, because our program was the first program in Russia. I used to joke about it. I was saying we are the best because we're the only one. Well, we're not the best because we're the only one. We're the best because we have best faculty. Our professors are all world-renowned professors from best universities in Europe and America. So those experienced professionals came in and got their degree. In fact, some people from HEC, from our university, now my deputy professor, Dmitry Zaitsev, he already had his PhD and he worked for a substantial amount of time. He enrolled in the program and finished it so that he would have hands-on knowledge of all these methods and tools and can use them both in his research and administrative work. So if by experienced professional, you mean people who already have worked in the industry, then yes, this program is wonderful for you because you know what you need it for. If by experienced professional, you mean someone who has had extensive training in data and maybe even network analytics or any data analytics, look carefully at our courses. Because if you already have, let's say, Masters of Statistics, you already had that advanced level training, or if you have a PhD, right? Because PhD has first 2 years of training on the master's level. Look how much there is intersection between what you know and what you will learn in our program. Because if you know all the topics we're already offering, then why enroll in our program? That makes no sense. So it makes sense if you come from a different field, but you do know very little about other analysis. So do I play the guitar? Yes, I do. How can machine learning be applied in the network analytics? We are using, well, machine learning is just, now we're down to say, it's a group of methods, right? Machine learning started with regression. That was the basic thing that we learned machine how to do, is to extract the true model from, massive data. Then we learned that we taught it to recognize pictures. Then we taught it to recognize voice. Now we're teaching it all sorts of different things. So yes, we do use network analytics together with machine learning, but machine learning by itself is almost like saying data analysis, right? It's just a field. So tools that are used to perform network analysis. Well, actually, there are several networks-only programs. For example, program PAYAK, which is PAUK in Russian, which is a spider, right? That's a program that was developed by our Slovenian partners, University of Ljubljana, Professor Vladimir Butager and his team. By the way, he is the person who developed this program, is not only teaching in our master's program, he is also the scientific advisor of our laboratory. But this is the best program on the market that analyzes big network data. By how big, I mean 10 billion nodes. So there are no other software programs out there that can analyze data that big. There is Aura, there is NodeXL. There are some other network-specific programs like Visoni or Gephi So, I mean, there are many of those, most of them are free. We heavily use R, and some people use Python. I don't like Python for networks. It's not as good as R yet. Now, SAS has a networks module. It's not good. Okay, so I use SAS a lot for other things, not for networks. So whatever you, I mean, in this presentation, if I get to that point, I'll show you the software we use. I mean, there are many of those. The cost of the program and how many credits are offered. So the program costs, the starting cost is at this point in time, $15,000 for the entire program. So for the whole duration. So it's about, and it also depends on how long you take to finish it. Some people can finish it in as short as 18 months. Some people will take the full 24 months. Well, it's actually 21 months. So it's 18 to 21 months. So that's entire cost is $15,000, but we do have discounts based on the country of origin and based on the time of application. So some discounts can be substantial because if you are from the developing country and you apply early, you will get a substantial discount. But of course, we can talk about that once we see your application. For developing countries, discount starts at 20%. You don't need to learn R and Python to register. How to access it, if you're very interested, there are some links. Please join them. We'll send you the information. The program is starting in September. This has grants from HEC. Like I said, we have tuition discounts. We don't have the grants. We can just reduce the cost. Criminal networks, excellent. Is it possible to do short courses? Yes, you can actually enroll in individual courses of this program. What we do offer starting in April is network specialization. It's called Networks for Business Analytics. Again, this is the only specialization like that in the world that I know of, because there is very little business networks in business analytics where business is all about networks. If you think about it, starting from financial networks, as I already told you and gave you an example, and ending with personal networks of CEOs. So we should use networks. Now, this is a certificate. It takes 4 courses, and you get a certificate that's $49. So you take about half of the course that's offered in the master's program. And then if you have desire to finish it, then we can make arrangements how you can take the full course. Do we provide services for an organization? Yes. As I said, we have 2 types of consulting services that we offer. One is completely free, that's offered by students and run by students. That's a part of their consulting course where they learn how to be consultants. It's actually, nobody's born knowing how to be consultants. And it's amazing how people think they can learn the method and then go and consult. I can see my students, it's amazing how they progress through the course. When they first see the client, they don't even know which questions to ask. When they see their 5th, 6th, 10th client, they not only ask questions, but they actually formulate the questions and help their client figure out what they want, because clients lots of times don't know what they want. Okay, you will learn that when you learn consulting. But the second part of consulting we offer is fee-based consultants, where we as the lab employees and the employees of the center for applied decision-making, analytics and decision-making, we actually have a full formal contract and we provide paid services. And we do have some very well-known clients. I worked for companies called Coca-Cola, I've heard of that, and the McDonald's Corporation, and and Volkswagen Corporation. Okay, so you can look at all of those on our website. Can you lead to do a doctoral program at HEC? Yes. Last year, 5 of our graduates of our program entered the HEC doctoral program. The full course specialization is available with Coursera Plus. Actually, I'm not sure what Coursera Plus is. If you send us the email, we'll give you the information about that. Well, let's actually talk about networks. Some more. Networks are insightful and fun, okay? There are simple models. When we just say, how do people influence each other? That's called models of social influence. There are more advanced models, models of social selection, for example, when we select based on their attributes. For example, we like some people, or maybe we don't like some people. So it's like, how do we do that, right? And then there are special network models. You actually asked excellent questions. Thank you very much. This has been actually one of the best webinars I've ever had, because you are so dynamic with your questions, and you allow me to, you make me think on my feet and come up with examples I didn't prepare already. And we talked a little bit about community detection. So you've asked me the questions where I've described those models to you. We also have what is called co-evolution models, and those are a lot of fun because you see how people changed based on their environment, and then how environment changes based on people that come to that environment. So that's co-evolution. So it's the society developing in a spiral, hopefully becoming better people as a result, right? We as a whole world. But that's the temporal networks that we study. And we have many, many others. And what I wanted to do is let you guys take a look at networks and actually show you a couple of things in R, what you can do with them. Would you like to see that? Or you guys want me to answer more questions? Because I kind of didn't plan for lots of questions up front, so I thought I'll have time for everything. Okay, so you want to see this. I thought that you want to see this. Let me open this real quick, because I think you need to see it. It's a lot of fun. In R, so it's taking a little bit. Okay. Can you see my screen now? Right? Okay. So this is the R Studio. For those of you who don't know R, don't be scared, because we teach you from scratch. We teach you to work with this. And I will show you a really fun example done by someone who has never done any R. So of course we have libraries, right? And this library for social network analysis is called SNA. And I'm going to set my working directory. Here's a classic study of drug users, people who use drugs, okay? We can use networks for that. We can see how people, who they get their drugs from. Obviously, they don't want all to tell this information, so it's not always the maybe easiest. Do I have exported library? I have it, no, it's connected, so I'm okay here. All right. So I'm going to read the data. That's called the drug page. That's a classic data set you can find online of drug users. And the first thing I'm going to do, of course, and notice how simple commands are. You will learn those commands very quickly. It doesn't take a whole lot of effort. But notice here we have our network. And remember how I told you that networks, the network pictures are not only descriptive, like they would be with standard statistics, they're also very inferential. You don't have to talk to me, but maybe you can tell me, what do you see here? What are some things you see? Pages from Payek, yes. Well, excellent, 2 groups. Disconnected nodes, clusters, wonderful. Hey guys, you already know network analysis. So see how you, basically all you have is a data set. You don't really have much going on. But in this data set, you have these 2 large components, actually 1 connected component, and then you have lots of loose nodes. Now we know these are drug users, so we don't expect them actually to talk to us a whole lot, right? So it's kind of expected. Now, when we talk to these people, well, not we, but people who have collected this data, they collected the data on their gender and on their ethnicity. And here I'm going to color the nodes. So just ignore the comments I make. I mean, the commands, you can just see that I'm programming something. You guys will learn to cut and paste commands. Stack Overflow is our best friend. After a while, you become so good at it, you forget when you learn to program in R. So it's very easy. So let's color our drug users by gender. Okay, well, that's not really very useful thing. See, what I have done is I colored them pink and red based, pink and blue based on gender. And I gave them the shape based on race. And I don't think I like that because I can't see much. I think I see more males than females, and that's probably true, but I don't see much more than that. Let's recolor this. Let's color them by race. Okay, what do you see now? With that, I don't care who the blues are, or purple, or yellow, or red. What do you see? Actually, you can tell that despite, we don't know much about these people, but we can tell that the drug users of different races hang out. Exactly, the clusters explain through race. Very good. So see, I don't know if you really know anything about networks, but here you are, you're already a network analyst. So basically, you learn to draw a picture and you can immediately make an inference. Now, can you do this with any other regular data analysis? So let's say, remember how you progress through your statistics course? You start with something and then, averages, standard deviations. Yes, you can calculate that you have so many people of one race, so many people of another race. But can you really tell how they're connected together without the network? I don't think you can. So in fact, I will do something that's not in the code. Okay, it doesn't have ethnicity. Oh, I misspelled. So see, I have 4 races. I have 99 of one, 155 of another. I think that's my blues and purples. This is regular statistics, right? But it doesn't tell me anything about data, about how these purples and blues are connected together. What it tells me, what I can do is I can only tell that with a network diagram. And it immediately becomes obvious. We can immediately make conclusions about our data. Now, what's also fun is you can rotate networks and you can look at them in 3D. So remember I told you about the Medici family when we started? So here is our data on the Florentine family's networks. And let's look at what we've gotten here. Guys, see this? Now, how cool is that? You can make your network 3D. You can actually look at these connections, okay? And tell who is who. We can actually add labels and look at that and, figure out where Medici is. Now, if you were to figure out who is Medici, which node do you think that would be? Can you tell? Let me try something here. Here they are our Medici. They're right here, that blue node. Let's get to it. Here it is. See how they are connecting several groups together. Like this group, that's one group of nodes. Yes, they're connected together, but not very much. This group, that's another node. They're connected together by not very much.
You didn't see anything.
Okay, so I have hung connection. So let me turn off the video. Actually, or did everything go dark?
No, we see your R, but it's still the old network. Yes, the dark net. I think it's
okay.
probably
You don't. All right. So let me show the 3D plot. So do you see changes on my screen or not, or is the screen hung?
No, I think you demonstrate only RStudio and maybe in this problem.
Oh, I see. Okay. Let me do something else. Well, unfortunately, my R is completely hung, so I can't. you know, what happened is my Zoom is hung, so I can't stop the share. So what I'm going to try to do is, if you hang on for just a second and get back, can you do that? Or do you want me to just answer questions and not show anything else? Because my Zoom meeting is not responding. Are you there?